Okay, now we are going to learn about the application of the Newton's law of cooling. Okay, so in this first sentence here, this is just a formula for you all. Okay, untuk Newton's law of cooling, dia memang dah ada specific formula. So this formula is where you gotta memorize them. Okay, so this is sort of like the important equation lah whenever you solve the Newton law of cooling. So what is Newton's law of cooling anyway? So let's have a read of the equation and the explanation here. So d theta dt is equals to negative k times theta minus theta naught, where theta is the temperature of a hot substance, okay, in degrees Celsius. And then theta naught is the room temperature. Okay, so room temperature perlu ada dalam formula. So the temperature of the hot substances will be minus with the temperature of the room, and then we times it with the negative constant k. So please bear in mind that k is actually positive constant, but why is it negative sign? Why is it? Because these hot substances will be cool as time goes by. As time goes by, the temperature of the hot metal will get colder and colder. You understand me? So you don't have to be afraid. You will know that any hot substances can get colder and colder in room temperature, right? That's why dalam formula ni mempunyai room temperature. You understand? So that's why the name of this application dipanggil Newton's law of cooling. All right. So let's read the question. I think it's better to get close to the example. So a metal is taken from the oven. Keluarkan metal daripada oven 30 darjah Celsius. A metal is taken from the oven at 300 degrees Celsius and placed at a room temperature. Biarkan dalam room temperature of 70 degrees Celsius. Okay, room temperature kita 70 degrees Celsius. So dalam masa 2 minit, the metal's temperature is 200 degrees Celsius. Okay, dah makin berkurang daripada 300 degrees Celsius menjadi kurang sebanyak 200 degrees Celsius. Okay, and then find how long does it take the metal to cool down to 150 degrees Celsius. So we gotta know what is the time to cool down until the temperature reaches 150 degree. Alright, you understand? So kita sekarang ni nak kena namakan dulu temperature tersebut kepada nama theta. So this is a theta. This is already given to you all in the formula. That's why you just follow it. So untuk temperature, kita memang pakai theta saja. Kita takkan pakai huruf lain, but mostly kita pakai huruf theta, okay? So theta is the temperature of the metal at time t, and so this is the information that I extract from the long sentence. So at time t, initially, the initial time is the metal is 300, very hot. Okay, and then after 2 minutes, the temperature dropped to 200. The temperature dropped to 200 degrees Celsius. So dekat sini you faham kan kenapa formula ni adalah negative sign? The formula is negative sign because the temperature is dropping. That's why dalam formula Newton's law of cooling mesti ada negative constant. Alright? So basically you already understand that. So this actually is your first marks. That's why you gotta memorize this. This is not given in the formula sheet in exam. No, they are not going to give you. So you must write it down, you must hafal, and then you get 1 mark. And then you will do cross multiply. Okay, you will do cross multiply. You will get 1 over theta minus theta naught d theta on the left hand side, while another one is negative k dt on the right hand side. And so you can integrate both sides. So after you integrate both sides, you will get ln theta minus theta naught. Okay, and then equal it to negative kt plus C. Sebab apa kita integrate the K with respect to T, we'll get negative KT plus C. And then we do what? We do exponent both sides, we eliminate the ln there. And so it will give you only theta minus theta naught bersamaan dengan exponent KT times exponent C by using the rule of indices. By this time, you're already very pro code. Okay, you must be very pro already with the rules of indices. And so you change this exponent C into the letter A. As usual, sama saja, pattern sama. And so you must make this QT as a subject. You make it QT as a subject, you will get equals to A exponent KT plus theta naught. Okay, so theta Q. Did I say Q just now? I'm so sorry if I said Q. What I meant here is theta. Jadikan theta sebagai subject, and then you akan nampak theta naught. The room temperature will be at the back now. Will be at the right hand side part now. Alright, so you understand me? So this is actually our general solution for the Newton's law of cooling. Okay, sama je. And so what do we have? We are given the room temperature. We are given the room temperature. How much? The room temperature is at 70 degrees Celsius. And so you suck in the 70 degree ke dalam theta naught. So basically you will get this mark. So basically sebenarnya the perfect general solution is actually over here. So this is your perfect, sorry, I want to use red color to show how important this is. So this is actually your perfect general solution. So this is your general solution untuk soalan yang berbentuk Newton's law of cooling, sebab dia mesti akan bagi dalam soalan dia punya room temperature. Dia akan bagi. So you must subs in that dalam equation kita. Okay, mesti begitu. Pattern sama saja semua soalan. So here we go. We are given the first information. This is the first info. So the first info here said that at time t, initially at time t, the temperature is 300 Celsius. So I put the time t here. The time t pula. I put the theta lah, the temperature theta 300 ke dalam kita punya general solution, sub it in and then put in the time t0 in it, in this general solution. And then we will get the value of A. Macam biasa, kita memang akan dapat nilai A dulu. Okay, dengan apa? Dengan time t0. It's always like that. It will always give you the initial time. Untuk mana-mana soalan pun, saya garanti lah semua soalan akan bagi kita initial time untuk dapat nilai A. Okay. And so, kita dapatlah particular solution, lebih hampir kepada particular solution. Tetapi kita tak ada nilai K. We do not yet have this value of K. We already have this value of A, but we are not yet getting to the value of K. So how do we find the K? We must have the second info. The second info will help you to get the K value. Okay, so the K value will tell you, will need you to have the second info, which is at time t 2 minutes. Pada 2 minit yang seterusnya, the temperature will drop to 200 degrees Celsius. So you masukkan nilai 2 di dalam particular solution di sini. Masukkan T ini ke dalam you punya solution here, and then masukkan juga temperature dia 200 di sini. Okay, masukkan nilai 2 dan masukkan nilai 200 ke dalam particular solution here. Sorry, general solution here sebab dia belum lagi dapat nilai K. And so you solve until you got the value of K. Hati-hati, the K value must be negative here. Okay, so and then if you already found your K value, you are so happy now. You can sub in the K value inside of this general solution. So when the general solution, we have negative outside. So negative bertemu negative akan jadi positive. Sama seperti radioactive decay sebelum video saya sebelum ini. So basically negative akan jadi positive. So this is your particular solution where everything is has been found. You have found the value of A, you already found the value of K, and you already sub in the theta naught, which is the room temperature. So you are happy, has successfully found the particular solution, and so you can uh, answer the last question here, which is, I mean, the only question here, which is how long does it take the metal to cool down? Okay, how long, which means T equals to whatever, how many minutes to take it into the metal 150 degree Celsius. So you tinggal pakai sahaja particular solution tersebut, masukkan sahaja you punya temperature yang diberi pada kita dalam soalan, which is at the time the temperature of the metal is 150 degree Celsius. What is the time then? What is the time? So dah dapat particular solution, senang menjawab soalan yang diminta. Dia minta nak cari time T, minutes. And so you solve. You do the mathematical process, uh, you solve it mathematically, and then you will get eventually the value of T, and the value of T will give you 3.70 minutes. And therefore, you can write down your conclusion saying that the time taken for the metal to cool down to 150 degrees Celsius is only 3.7 minutes. Okay, so I hope it's not too difficult. So far, it's not that hard if you really, really understand the questions and you can extract the info out. There is no problem at all for you. Okay, so good luck.